The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we've initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Data Science, Runway, Powering Customer Insights. Our guest speaker today is Animesh Tripathi. He's a Manager Data Science, Data Technology at PayPal. Animesh has 12 years of diversified experience in providing end-to-end analytics innovative solutions for data and customers with focus on business intelligence, big data, data analytics, SaaS, OLTP, and data warehouse. He has 28 indexed publications in EEEE, ACM, and Springer to his credit that deal with innovations in database analytics frameworks and security. Currently, Animesh is working as a manager data science and leads a team of big data engineers and data scientists in Data Technology APAC to build data science engines for external teams to optimize PayPal products and business decisions. Prior experience includes that of regular consulting roles at Satyam, Wipro, TCS, TIG, and KIIT. His current interest is in data analytics and big data and would certainly add value to the customer data and help business grow at PayPal. Apart from his work, he loves listening to Indian and Western music, play cricket, and table tennis. He also loves traveling, meeting people, and socializing. So without further delay, I introduce you all to our guest speaker. Over to you, Animesh.
Hey, good afternoon all. This is Animesh and I work as a manager for data science at PayPal. So I'm happy to share some of the insights, some of the work, some of the technologies, and some of the use cases which we have been working on. So sorry for this background noise because there's some announcement, but please ignore that. So let's continue. So the insight or the customer insights which we are working on is primarily based out of data science and building data science as a platform in a long run. That is what is the dream. So data science runway powering customer insight is something which definitely interests everyone. But what goes in building a data science as a platform or data science as a runway is something all of us needs to know. Going by the data or going by, so there are various buzzwords like big data and others. So if you look at the current stage, we have a lot of consumers. Consumer in telephone domain, consumer in online domain, consumer in digital world, consumer who buy, shop, dream, live, eat, drink, all online. So they might forget their wallet, but they'll not forget their mobile device, right? So primarily, if you look at, there are 2.4 billion internet users as on date. So this is fairly last year's data. And they are all interconnected. So if we look at anybody living in India or anybody living in US, so everybody is interconnected through the power of Facebook, Twitter, LinkedIn, to name the biggie ones. But yes, there are other various channels through which they are interconnected. And thus, it helps us, gives us an opportunity, gives us leveraging all the technologies, how we can build something which will help those people to manage and grow intelligently. So a famous understanding, or the basic understanding which I want to begin before we get into the couple of use cases or couple of problems which we have been working on and have got great results. So before that, how do we really identify or distinguish between analytics, BI, which is nothing but business intelligence, and data science? So primarily, we try and, so all the industry, anybody working in the BI domain, try and simplify BI. Try and find out that what BI is doing so that they can develop some tools and technologies which reduce the complexity, latency, and which empowers the business users to grow. Whereas if you are looking at analytics, so analytics is very tricky. Everybody says we do analytics, we do BI. But analytics, from my standpoint, is very tricky because analytics has emerged as the catch term, as we say, right? And it is used for a variety of BI applications. So every known vendor in the industry, they say this BI does analytics. And they have increasingly analytics being used to describe all statistical mathematical methods and to derive some kind of data analysis, forming some clusters, some segments, give merchants some scores, predict some scenarios, but how far they are into that whole world of generating analytics is something which we need to look at. Whereas, if you are looking at data science, which has come in fairly recently into the industry scenario, if you are looking at digital and online business, where we have data which is almost end-to-end, and those data needs to be understood in a very proper way. So if you are looking at what data science has done, so data science primarily combines big data, and when we say big data, we focus on the fascination of unstructured data, the precision of advanced mathematics, statistics, and what social media has added as innovations to the whole capacity, and how to create, investigate, inquire, and how to use all these abilities together so that we use those skills and we build some solutions which is intelligent, which focuses more about predicting, and more the application itself behave like more like a human being. So we all say we are intelligent, and we are proud to say we are intelligent, and how data science can make those applications more intelligent. So going forward, if we try and build data science Runway as a platform, then what are the challenges industries, every industry including ours, face? The first, there are two broader aspects. One, the community building activities, which primarily focuses on how to build a community of data science. Right? The second is more on the infrastructure side. So in community, the first primary source of building it is how to get the talent, how to get data scientists, how to get the whole data owners, how to primarily build that community so that they can start working and building some intelligent solutions. Whereas on the infrastructure side, when we say unstructured data, big data, so we need distributed system which is highly powerful, which has lot of memory, lot of processing speed, lot of in-memory devices, and lot of different kinds of, so whenever we are building any platform, it is again, I know post I'll have some questions definitely where you might be thinking of asking what do we use at PayPal, but taking that little ahead of time is whenever we are building any infrastructure in a big data scenario where data science is the primary focus, there are multiple analytics software, there are multiple tools which can be used, and you have to literally pick and choose and find out which suits best to your needs. And once you are trying to build that infrastructure, you have to monitor and manage on the long run. So I just wanted this particular view, what you are viewing currently, just to give you a feel that there are multiple tools, multiple platforms, multiple visualization tools, multiple libraries which are present. There are multiple open source platforms which you can use, and it's rather saying that I can use this for this particular solution, it is rather saying that what suits you better. And there are multiple programs, there are multiple platforms, so you can choose anything on that. So let's try and understand more from a design perspective what we are looking at. So we are looking at building some intelligent solutions which will process data, and the solutions is going to give us some great results, some insights, right? So whenever we do that, my primary understanding or primary objective of making you understand is at a very lower ground level is that whenever we try and execute, because these are all databases, huge databases, large data stores. So SQL or SQL is pretty powerful to execute whatever you want to do, and whenever you are trying to connect to any data store, so all the processing happens at the data store. The algorithms live on the machines where you are trying to operate, whereas the data store is going to process those high-end programs within the SQL, and you will get some results in terms of some visualization. So this is fairly fundamental. But what are the applications of analytics which add values to customers which we have at PayPal? So what are our customers? So whenever we are looking at our customers, so our customers are primarily the consumer and the merchants. So to be very precise, they are none other than the buyers and the sellers. And whenever we are trying to do some application-based analytics which can add value, there are few of them which are there on the slide currently. The first one is community detection analytics. We'll speak more on that in our future slides. Second is definitely sales and marketing. So we can do a lot of sales and marketing stuff, and really data science has come a big way in many industries as of today, which have identified great models, built some innovative solutions, and they are getting good results in marketing and sales, including ours. Then definitely some data quality analytics, and we cannot ignore the social media. So we also source for social media feeds, the data which comes in as feedbacks, the feeds, the Twitter handles. So we try and use them. And as a company, as a payment instrument company, as PayPal, we have lot of data, lot of models, lot of solutions which is focused around risk. So there are a lot of opportunities in doing risk analytics, where we can primarily detect frauds, reduce losses for the company, make the customer experiences much better, and definitely customer care to go by that. Now, as I said, we'll be speaking more on a couple of them, given the time and the opportunity. So if you're looking at that, the first primary one is the community detection analytics. So what exactly is a community? So community is a community when we say it is primarily a group, a cluster of people who are like-minded, right? So forget about online or digital world, but general community. We can say I stay in a community. So what it means that I stay in a locality where I have like-minded people like me and I enjoy living there. Similarly, whenever we look at a community, they definitely share similar taste, similar interest, and similar behaviors. Why community analytics matter to a company like ours or any industry domain which has large amount of data with respect to consumer is we can really find out deep customer insights. And those customer insights which are hidden in the data which we collect are the challenges which we need to overcome so that we get to understand that yes, these communities helps us or this insight helps us in understanding our customer better, right? So our customer, when we say, we speak about the merchant and the consumer in our case, it may be some other in other industries. But primarily whenever we are looking at a community, we are trying to look at what are their similar interests and how exactly we can build a community model and draw some analytics on top of that. Now, how we do it at our place, a very high level understanding here. So we identify the like-minded communities from the online data source. Okay. Now, online data source which we have could be structured as well as unstructured data source. Structured data source in terms of the transactional data primarily. So being at PayPal, whatever a buyer and a seller interact or whenever they interact making a payment using any of our payment instruments, so we capture all those data. So that is all transactional data stored. And definitely whenever they make a transaction, they are definitely interacting with the sellers. So we have data with respect to sellers, with respect to the buyers who are buying it. So that is more structured. But whenever we are looking at the other means of capturing online data source, so data is much like a new currency these days because data is something which makes a company grow faster and take intelligent business decisions. So the unstructured data source which we capture in case of ours is all clickstream data, all unstructured data source with respect to the feeds which comes in from social media, and we have other means of third-party tools which capture some unstructured data, the call logs or the CAL logs, the IP logs. So there are a lot of unstructured or semi-structured data, you can say, and we take all of this data and then try and understand how exactly we can build a community. Now this data source as I am speaking may reside on for any industry on a EDW, which is the Enterprise Data Warehouse, or these days if people are familiar with Hadoop, so they might reside on SDSS, Hadoop file system. What we do when we have this data source, so we try and understand that what exactly is the deep insights we can identify on a single customer, right? So from a customer standpoint, if you look at what are his preferred products, what is the length of time as a customer, so how long he has been with this particular, let's say, product which he is buying, or he is buying buying behavior as a consumer, and when did he become a consumer, when was he enrolled as a consumer. So that's the length of time we are looking at. Then what are the preferred channels? What is the channel through which he interacts? So for us, we have multiple different channels through which a customer can interact with PayPal. And then we can identify the buying frequency. Definitely this is very simple to understand, because whenever a customer interacts with PayPal, definitely he is using PayPal for buying or purchasing something. So we can identify the frequency. We can identify his interest. So given a customer we have, we can identify what exactly the customer is doing on PayPal, right? How exactly, what is his buying, what exactly is buying, what exactly are his interests, which products interest him, when does he shop? He shops in the morning, afternoon, he shops during after lunch, post lunch, or he shops late midnight. So we can identify data with respect to that also. And definitely whenever we have consumers who are online and using the digital media, they definitely will have some browsing pattern. So we take that data as well. And then designing some models, and if there are some campaigns which are run, what is his response to the campaign? We send him some campaigns. How is he responding to the campaign, right? Now once we get all this deep insights or all this deep understanding, we try and identify like-minded communities based on all this input. So these are nothing but the input parameters to build a community in this case. So primarily we are looking at who is buying what, who is interested in what, right? So all who, what kind of scenarios, and then when we try and build the interactions between them, we try and understand from a product standpoint, from a service standpoint, from an interesting measures standpoint. And once we are able to do that and build in some intelligent solutions embedded there with some innovation, then there's nothing stopping, because once we have that, we can roll it out to the sales marketing campaign. We can have dynamic recommendation and promotion. We can have churn prevention. Now, churn in our case or an industry like ours is mostly from a merchant or a customer standpoint. So what is the merchant churn? Can we predict that? Can we predict the consumer churn? Can we predict the buyer and seller churn, right? So that is one area which we can look at. Next, this is pretty interesting. So can we get into white space customer targeting? Can we get into adding new customers to PayPal? Right? So a typical example, I wanted all of you there on the other side to understand that what exactly a community analytics, a use case can look like. Now, whenever a person is buying something or a buyer is purchasing something, right, a sample input could be in this format, right? So we try and identify what exactly is buying, right? So we may not have data there, but there may be logs where this gets stored, and we try and identify that what is his transaction history. If he's purchased 7 items, what are those 7 items, right? So we build primarily a consumer cart or a cart for each consumer, and on the merchant side, we try and identify that for each merchant, what are the transaction history which has happened with respect to the items which have been brought by the buyer, right? It can be as detailed as something which is there on the slide, 750 GB SATA 35 hard drive for HP, this, or it can be as high level as a battery or an iPhone or a phone, right? Or even much high level as what the merchant is primarily at. Is he a electronics merchant? Is he a fashion merchant? Is he a cosmetic merchant? On that account. Once we have that, then how do we do? So how do we identify or build a community of merchants? So this is one example. This is just one such example. Nothing on that this is the only example, but this is one of those cases which we have done. So we try and build a community for merchants. So we try and identify who are the peers of that particular merchant, who are people who resemble very closely to the merchant we are identifying or the merchant in focus. So if we look at that, then we try and see what is the overlap between a merchant and the other merchants who are taken in scope. And then we find out what is the similarity, right? There are multiple similarity things or similarity coefficient which you can use, okay? So you find out the similarity. So once you find out the similarity, then probably you can say, yeah, out of these merchants which are in scope, A1, A2, A3 seems to be very closely resembling each other. So can I build a community for them? Yes. If I can start building a community for them, then if those communities are exactly in scope, then if I try and understand or if I try to identify a behavior of a individual merchant in a specific community, can I apply those things to the other merchants? So that is how a community for a merchant can be built. What are the challenges we faced? First and foremost, every model or every such model which I will be speaking today is all dirty data, right? Lot of junk, lot of end of file, lot of product names. Different merchants in different countries have different product names which do not match, but they exactly mean the same product, right? So different merchants will have different sites, websites, e-commerce websites, right? And then we try and see that how exactly those products can then be grouped together. So now whenever we see products here, we are looking at how to build a community for a product. And definitely, yes, there may be a variable number of transactions which happen over a period of time. So how did we handle that? For dirty data, we used regular expressions, right? And for different formats, we tried and used tokenize based on or building tokens based on the product name. And yes, this is stuff. This is stuff in the sense this is all junk, and you start from junk and try and leverage the power of data science and see if you can really power the commerce or the e-commerce and build some intelligent solutions which can then give some insights, intelligent insights to consumers. Now fairly simple. Once we have that, definitely each of the community, when they try and interact within themselves or within multiple other communities, you will have graphs which are formed. I am trying to make it a little simpler. I hardly know the audience on the other side, but once trying to make it a little simpler, so you have graphs, you have partisans, we can use graph partisans there. So this particular example is trying to understand that yes, we can write some MR jobs, map reduce jobs, we can write some mappers, reducers, okay, and this will help us in executing parallel algorithms and using the massive parallel processing structures. Now, the next one is pretty interesting. The next one is the CSR Data Model, which we have started working on and which gave us good results. This is nothing different from what is simply a recommendation system, but we try to do it a little different. So we try and say that how can we connect the items or the products? How can we suggest products based on the connections which we get? And how can we recommend different consumers, different merchants, and connect them primarily based on these recommendations which we have? Where can it be used? Yeah, it can be used in EDM, a very popular model where we use for electronic direct marketing. So connect, suggest, and recommend. This particular data model which we built on the data science platform was primarily able to identify what offer can be given to which set of consumer and what is the likelihood of their buying pattern and behavior and how exactly they can use this offer so that they get maximum benefit out of it. We get maximum benefit out of it by enabling more consumer into the system. So you can specifically roll out specific focused offers to a specific set of customers. Now something which is catching up is deep learning. Now deep learning in this particular example, if you look at, so it's more on the image side. So given the image of a bike, and we identify the image components there in terms of handle and wheel, and then try and build some learning algorithm on top of that and identify a feature representation in terms of the handle and the wheel, and try to plot it. So we have the motorbikes and the non-motorbikes. So can we identify with the help of deep learning using graphs or images that what exactly are the motorbikes to be classified as and what exactly are the non-motorbikes. So when we say non-motorbikes, it includes everything else. So to identify a motorbike, what are the features we need to concentrate on? So in this particular simple example which I wanted to focus is primarily if we say we have a handle and a wheel, these are the two features, and we have some learning algorithm which learns these features, then can we identify in a space and given a scope of multiple different images, how many of them are motorbikes and how many are not? So we are not looking at visually which are motorbike, but we are looking at a feature matching algorithm which will match those features and identify whether they are motorbikes or non-motorbikes. Similarly, one such usage which we used was RNN, Recurrent Neural Network. Now, what happens in RNN is, if we put it a little simpler, it identifies a sequence of events. Okay, so if I have a sequence of events which is occurring, can I have a layered structure where we all know that we have an input and output? Can I identify the hidden layer on a given time scale? And if I can do that, and if I can get some population built on the sequences which we identify, can those populations be popular so that can I use it for predicting what could be the next thing which is going to happen? So if I say he is good at box, so what is the next alphabet which is going to come in? Can I use the sequencing which happens in every possible place where if BOX is there, what could be the next alphabet? Is it I? Yeah, it may be I. So is it boxing? Yes. If we see the population and the popularity of BOX followed by I and then by N and then by G, and if we say it is boxing, then we can map this exactly to the same sequence. So how it is helpful? It It is helpful in our case where we can map it directly to the buying pattern of a particular consumer over a period of time. Now, interesting enough, what we are looking at is, given a space, so this is just a data scope. So given a space, given the total volume of transaction which happens, so assume we have multiple merchants and we have large merchants, we have small merchants, we have merchants who lie between the large and the small merchants, right? So we have different segmentation of merchants. Now, if we segment merchants based on, let's say, the number of transactions which they process, or the amount of predictions, the amount of volume which they make, and if you do that, then from 0 to 1 million, if we take a band, and if we take another band from 1 to 2, another band from 2 to 5, and some band which is greater than 5 million, then we say all merchants who belong to greater than 5 million are all large merchants, and then segment the merchants based on the number of transactions they do or the total volume of transactions which they process. We see there is a very interesting identification. If we try and do that, then we identify, so these are in millions on the left. So if you do that in North America, NA stands for North America. If you look at North America, the 0 to 1 million, the merchants who process 0 to 1 million transactions are more as compared to the large merchants. Whereas if you compare it with Latin, okay, so you find that we have more large merchants as compared to the merchants who are processing less volume of transactions. So this gives you a feel that, yes, can we build models uniformly which will suit all requirements? The answer is no. You have to look at specific focus group. You have to build specific features. You have to identify the parameters and then modulate those parameters over a period of time, looking at the generic understanding of the interaction between merchants and the consumer, and then regulate it to build a model. Now, interesting enough, once we tried doing this, one of the very interesting model which we built was the risk data model. Now, so being a payment company, what exactly we try and do here? We try and do here is the merchant selling drugs or weapons, guns, or any authorized products, and we are processing it for them, and we are helping the buyers to buy that. So that's the risk. And to do that, we try and identify the merchants for whom there was a risk, and they have been identified as merchants who have had at least one instance of processing such kind of products which are unauthorized. Once we do identify that, then can we put them in the same bucket as peers and see if the behavior of a current merchant is this and it matches globally to a certain group of merchants who were identified selling unauthorized products, can we still apply more checks on the current merchant who has a trending behavior of selling some unauthorized products in a couple of months? So that was the challenge. So we try and identify the violation which can happen, and then bucket the merchants and process their transactions having multiple more checks as compared to the other merchants. A very interesting feature which we tried building was the MCC. MCC primarily stands for the Merchant Category Code. So whenever a transaction happens between, or whenever there is a transaction which gets processed between a merchant and a consumer, So there is MCC which gets transferred or tagged primarily in the data. And we use this MCC for each merchant. So each merchant will have a different MCC. Can we use these MCCs or the merchant category code to identify that yes, these merchants sell different kinds of items, and can we tag them at item level? Can we use these MCC for generating more revenue? Can we use it for pricing? Can we use the data which we have using this particular model mainly to earn more revenue? And can we see globally what is the distribution of the revenue which we earn? Now, going forward, what I wanted to focus on this particular platform was how exactly a data science platform, or people speak of data platform, people speak of operating system as a platform, people speak of many different kinds of platforms. Can data science become the next big thing in the industry, which many of the big industries, the larger ones, have already identified that going forward, if we try and identify what exactly a consumer or industries which mostly target on the customers, let's say telecom industry, a online e-commerce industry like us, right, or a banking industry where you have a lot of consumers on both sides, and you are making the consumer understand that what exactly the consumer transaction processing systems can happen. Can we build data science as a platform, and can we leverage those platforms to build more consumer insights? So I think for a generic understanding on what exactly data science can do with, so I showed you a couple of use cases on this platform. One is the Connect Analytics one, and the second one was more on sales and marketing. So thank you. I will open it for questions if there are any.
Thank you, Animesh. Thank you so much for the insightful presentation. Let's quickly take up the questions now. I would request you to read them out and answer them. Okay, because we haven't got a lot of questions right now. I mean, there is one that I can see. I will hand over the session to you, and then you can read out the questions and their answers so that all our users may listen to the commendable insights.
Yeah, so I have the first one. Let me take it. So Jayendra Kulkarni, thank you so much for attending this, and it was good to have you. So the first, the question which he wants more understanding is, what was PayPal system different from Amazon? Or yeah, I was expecting this. So how PayPal is different from Amazon, or how exactly we differ from Amazon as such? So primarily, if you look at on a very simple understanding, Amazon is an e-commerce platform, where PayPal is a payment platform, right? So whatever we have with respect to any of the e-commerce companies out there or industries out there is different. What we have here is we have an end-to-end collection of data and understanding the customer in more deeper terms, because we know that when was the item purchased, what was the instrument which was used, what was the mode of currency which was used, where is the merchant, where is the consumer, and what exactly the consumer is trying to do, and based on his behavior we try and do our analytics based on the data science. Whereas for a company like Amazon, they will have little more data, right? They will have data with respect to the products, they'll have data with respect to the merchant catalog, they'll have data with respect to the person's browsing pattern and all of those. So I hope I did a good job, but if you have more understanding or if you need more clarification, please reach out. The second one I have is from very interesting one. So it is from GVA Babu. So thank you, Babu, for attending my session. So what he wants to know is, what is the difference between a data scientist and a data analyst? Now this is a very interesting question. So data science, so when we say science, so science itself is a culture, is an art, right? So science is much different from what an analyst does. An analyst primarily looks at the data which is visible to him, right? So whatever data is visible to him at one go, he tries to play around with the data and analyzes based on the data which is visible. Whereas whenever we are looking at a scientist or a data scientist, most importantly, so a data scientist in a very interesting term understands the hidden behaviors, try to find out the hidden patterns, try to identify any hidden insights, any kind of information which gets stored there, and does science with data rather than just playing around with the data to understand it better, right? So I store it in multiple columns, I have multiple views of the same data, so that primarily is what a data analyst does. Yeah. Going forward, yes, there is a very good scope of a data analyst or a community of data analysts which we have in our company as well as in other industries to do little bit of more learning on data science, emerging platforms and tools, and build their career if they want more into the data science. So they plug in a very interesting way. They're all in the same community, close by, neighborhoods, but not in the same place. Yes. So the next one is from, so this is very vague, but yeah, I will try and see if I can answer this. So it is from Vinu Priya. So thank you, Vinu, for attending this. So his question is, what is the optimum accuracy rate for any data analytics? So if I understand it better, that if we are building any models and we are trying to, let's take a simple example, if I'm trying to do a weather forecasting, right? So assume I have a data science algorithm which runs and tries and identify the weather prediction, right? Or let's say I try and predict what the consumer is going to buy tomorrow, right? Or the very famous use cases of market basket analysis. So if you look at all of those, the accuracy rate is pretty. So there is no check, right? So the more accurate your predictions are, the more better is your model. But to start with, I would not say from my experience saying that, yeah, 40% accurate, your model is good, 70% accurate, your model is great, and 90% accurate, your model is best. It is not like that. So once you try and build a model, you try and see how much accurate the model is, and these models are always learning models. So they learn on their own. So once those models are there, they will again get to learn. So if I do a prediction, it goes wrong. So I try and identify why did it go wrong. So did I not capture the features correctly? If not, let me capture the feature and then fine tune the model so that next time I don't, at least I can identify this particular feature. Right. So I hope I pronounced the name correctly. Apologies if I not. So Hekuran Hazdari, thank you for attending the session. So his question is, most of your talk was about business level and data science, but how much data science can be used for a health industry, and what are its effects of different drugs on different nations, right? So yeah, I am not a domain of health industry, but what I can see as an expert here is, yes, data science can be applied to everyday life. So anything which is happening and we have data to play around, we have data to be usable, or if we have data to build something, there is a challenge, there is a motivation, and there is a clear objective of what we are trying to do, it can be applied to any industry. And health industry, definitely yes. So there are many, many great implementations of health industries. I do not know specifically, but what I understand from, I can give you an analogy. You visit a doctor, right? So when you visit a doctor, so the doctor tries to ask you different questions, and these are nothing but the symptoms. So these symptoms, based on the symptoms or your description, the doctor is going to prescribe a medicine for you. It is not that everybody who has fever will take this particular medicine, right? So there are multiple other things which are captured, and then a prescription is prepared. Similarly, that is a usual behavior of predicting probably you will get cured using this, right? But yes, there are many, many other situations where in health this can be used. So the next one is from Colenso. Thank you for attending this. I hope the time zone was good for you. His question is, what kind of information needs to be captured to derive useful conclusions on buying patterns? Very specific question, excellent one. Thank you for asking this. So what are the information we need to capture for understanding the buying patterns, right? So to make you understand a little finer on this, so we primarily have a customer cart, right? So when we build a customer cart, we try and see the first kind of behavior could be what exactly you are buying and what is the frequency at which you are buying. So that is the first kind of buying pattern which we can analyze. Second, based on the demographic, based on the time you are shopping, based on different other details, you can easily identify that what is the exact pattern on which you are trying to shop or trying to buy. So the conclusion which you have asked is, based on these data which is collected as patterns, we try and study them and then come to a conclusion that yes, this is probably going to be the next step for the given buyer. Okay, so the next one is from Jayendra. So Jayendra Kulkarni, thank you for attending this. So his specific question is, are your data analytic results available to vendors so that accordingly the vendors can decide his strategies? Excellent one. So we don't do data science in isolation, for sure. We don't do data science for our understanding or internal in the company. Definitely it is passed on to the vendors. Definitely it is passed on to, for us, the vendors can be at various levels. Vendors can be simply a merchant. Vendors can be a partner. Vendors can be a group of merchants. So if we are doing analytics based on data science for the vendors, definitely it will go to the vendors for sure. But in what capacity it goes, that is where we identify the relationship between the vendor and with PayPal, right? And based on the level of association and based on the level of understanding of the vendor doing business with PayPal, we try and provide insights. But yes, all the results are passed on to the vendors, not directly, but definitely in forms of, let's say, for example, how the vendor is doing compared to his peers in the market. So that's a very interesting results which we pass on. But we don't say who are the peers, right? Next. So I have a couple of minutes. I have multiple questions on my question board. So please do reach out to me through other channels if you want more clarification. So I'll take the last one, which is from Sachi Sharma. Thank you for asking this. What kind of experience and background is required into data sciences? Excellent. So as I said, data science is an art. So you can't do a course and get into data science. People believe that that's possible, but you need to understand it's an art. So you need to understand data better. So to understand data better, you have to equip yourself with multiple different skill sets. So the skill sets which are there is definitely related to the technologies for sure, different tools and technologies. Second, definitely the knowledge and the expertise on the different methodologies and techniques which can be used in those tools. For example, the data algorithms, or somebody has asked, so let me put it in the same bracket, somebody related to the data mining algorithms, all right, machine learning algorithms, deep learning algorithms, right? So all those, plus definitely yes, to add to that, you need to have the domain experience to understand what exactly is you are expected out of it. So it's the end-to-end understanding to have your experience and background build on data science. But data science as a platform, data science as a career prospect is good, and I welcome you if you are interested to build your career in data science and try and focus more into that, because this is the next big thing which is there. So thank you all for great set of questions. I know I cannot answer all of them, so I have answered some of them, trying to cover most of them which are relevant to this topic. So thank you.
Thank you, Animesh. I'm really thankful to our guest speaker, Animesh, today for conducting this webinar. It was indeed a great session. I'd also like to thank all our participants for their support in making this webinar a success. The recording of this session will be available on techgeek.com very soon. Thank you, everyone.
Thank you, Deepika, for moderating this. Thank you so much.
Thanks a lot.